Today on How It's Made. Race car oil tanks. Plaster moldings. Lemongrass oil. And fly tying vices. In race car engines, excess lubricating oil is stored in tanks rather than oil pans. This prevents the oil from sloshing around during the race and causing drag on the crankshaft. With less drag, performance is increased, so these oil tanks are part of a winning strategy. Race car oil tanks come in various shapes and sizes in order to fit into different vehicles. But their purpose is the same: to keep excess oil out of the engine to boost performance. Each tank starts with a computer design. The engineer maps out the precise dimensions. They input the measurements into computerized machining systems. This first one cuts a long piece of aluminum into smaller pieces, creating blanks to make parts known as tank rings. A vertical milling tool sculpts a recess in the blank to seat an O-ring sealer. Then, switching bits, the machine contours the outside of the blank, taking it from rectangular to round. Other tools carve a large hole in the center and profile the inner diameter so that the part will mate to the tank. This ring is designed to be removable to access the tank for maintenance. Here's the blank before and after machining. Like powerful cookie cutters, computerized punches cut out numerous parts from an aluminum sheet. They include the oil tank body, the top, and other assembly pieces. To make the tank body cylindrical, a worker turns a crank to curl it around a roller. This tank body is called the wrapper. He drills a hole in the bottom cone. The hole is for the line that returns lubricating oil to the race car engine. Using a thin bandsaw, he trims the cone to fit the tank ring. With a device known as a hydraulic tube bender, a worker shapes a piece of pipe to a precise radius. This pipe will be used to vent air into a chamber at the side of the oil tank. He trims the ends of the vent tube using a bandsaw. A worker welds the tank ring to the bottom cone, creating a thick seam all the way around. He then seals the seam of the cylindrical wrapper body and welds a top cap to a de-aerating baffle. Air will rise through it and vent it into and out of a side chamber, leaving only oil in the tank. He slides the baffle into the wrapper body. He inserts the vent tube in a hole on the side of the tank. He fits an adapter ring to the upper lip of the tank and taps it down with a rubber mallet. He welds the baffle and filler neck to the tank body, and then assembles the air vent chamber to the side of the oil tank and welds it to it. Moving to another station, a worker now taps perforated plastic inserts into holes in the air vent chamber. These inserts will both vent and filter the air from the tank. He fits a rubber sealing ring around the fill neck and screws the cap on. He applies adhesive back decals to the tank for branding purposes. He caps the oil inlet tube to keep contaminants out during shipping. He turns the tank upside down and installs a valve on the bottom of the vent tank. He inserts a rubber O-ring into a groove on the base of the tank wall and tucks it into place all the way around. After equipping the fittings on the cone with caps for shipping, he installs the cone on the base of the tank and screws the ring tightly to it. Accessing the tank for maintenance reasons will mean unscrewing this part. That completes this race car oil tank. Hooked up to a system of pumps, these tanks will receive and dispense oil sparingly to improve engine performance. They've been well equipped for life in the fast lane. The ancient Greeks first began beautifying interiors with ornate columns and moldings shaped from plaster. Decorative moldings were a popular design feature in much of Europe from roughly the 17th century onward, with Italian tradesmen becoming famous for their mastery at plasterwork. Specialists in traditional plasterwork are a rare breed these days. But that's who you need to hire to properly repair plaster moldings in a historic home, or to craft plaster moldings from scratch. To repair this damaged ceiling medallion, the plasterman first saws and chisels off the problem portion, clearing a flat work surface. Then he drives in screws part way to anchor the new portion of molding. The heavier the plaster molding, the more screws you need to hold the load. Another plaster man, meanwhile, prepares the plaster. The first ingredient is lime compound, a simple mixture of lime, also known as calcium hydroxide, and water. He forms a well with his scraper. Then fills the well with a mixture of roughly 3/4 water to 1/4 construction-grade bonding glue. just the right amount of plaster of Paris, which is powdered gypsum, the same stuff they use to make casts for broken bones. He takes his trowel and thoroughly blends the lime compound, glue mixture, and plaster of Paris. When it has the consistency of pudding, the plaster is ready. The plasterman does this all by eye, without ever actually measuring a single ingredient. After applying bonding glue to the repair area, the other plasterman trowels on lots of plaster. Then he takes what's called a circular running mold. Its profile is that of the existing molding. He runs it back and forth over the wet plaster, hence the term running mold. Then he carefully scrapes away the excess and runs a wet paintbrush over the new and old portions of the molding. This makes the transition between the two appear seamless and smooths out any imperfections. To make the running molds, he cuts out a cross-section of the existing molding and traces it to produce a sheet metal template with the same profile. Then, with that, he cuts the shape in wood, producing what they call a stock. After sanding the stock smooth, he screws on the metal template. The wood backing prevents the metal from bending as he runs it over thick plaster. He screws more wood to the stock to form a handle. To make crown moldings, the plasterman mounts a track to guide his running mold. He checks for anchor screws obstructing the path. If he finds any, he drives them a bit further into the ceiling. He brushes on bonding glue and lets it sit for 5 minutes. Then he begins applying the plaster in sizable globs. He passes the running mold over the plaster. He repeats several times with additional plaster, waiting 20 minutes or so between coats to let the plaster harden just enough to hold the shape. He applies the final coat by hand, filling in crevices and imperfections. Then he passes the running mold one last time. The wet plaster molding takes anywhere from 48 to 72 hours to dry, depending on its size and on the humidity in the room. Only when the molding is completely dry can the plasterman begin the next step, crafting the corner pieces called miters. Starting with larger knives and scrapers, he uses the edge of the adjacent moldings as a guide, adding some plaster, sculpting it, then removing the excess. He keeps repeating these steps until each side of the miter matches the molding it joins perfectly. It's a slow and meticulous process that takes patience and an expert eye. Once he has perfected the profile, he refines the edges with smaller knives and scrapers. Finally, he blends the surface with a wet brush, rendering the transition from miter to molding visually seamless. yet distinctively old world. Lemongrass isn't just a culinary herb. Oil distilled from the plant is a popular ingredient in soap and spa products. Used in aromatherapy for numerous therapeutic reasons. With a fragrance that's citrusy yet sweet, lemongrass oil definitely passes the smell test. Follow the scent of lemongrass, and the trail leads to Thailand. It's here that the plant is grown and processed into an essential oil. Lemongrass oil is the signature scent in this part of the world. After harvesting lemongrass, workers select the most fragrant specimens and dry them. They transfer these plants, stalk and all, to a distillation facility. The heady aroma of lemongrass will now be concentrated into a potent essential oil. Workers unlock the top of the still and pour in chlorine-free deionized water. Once the still is 1/4 full, they add the lemongrass. They stack the bundles in a crisscross fashion, creating gaps for steam to pass through. They filled the still to the brim. It will take 66 pounds of lemongrass to make roughly 1 quart of highly fragrant essential oil. They screw the lid tightly to prevent the loss of steam during distillation. They activate the still, and it heats the water to the boiling point. Steam rises through the plants and picks up the oils. It carries the oil vapor up through a pipe and into a condenser, where the vapors cool and return to a liquid form. The liquid oil and water drip out into a flask. Oil and water don't mix, so the oil floats to the top, and the water is drained off and recycled back into the distiller. The technician then collects the lemongrass oil in a bottle, 1 drop at a time. The lemongrass oil undergoes a second distillation in a laboratory, using a more sensitive piece of equipment known as a rotary vacuum evaporator. The oil flows into a flask that's spinning in a hot bath of vegetable oil. The evaporator pumps out air and creates a vacuum in the flask, which lowers the boiling point. This prevents damage to the delicate molecules responsible for the lemongrass scent. The oil vapors rise to a condenser coil where they reliquefy, leaving any residual water and impurities behind. The pure lemongrass oil drips into a receiver flask. As distilled lemongrass oil is collected, more flows into the evaporator beaker for purification. The distilling process is continuous. The rotary vacuum evaporator processes roughly 2 to 3 quarts of fragrant oil per hour. They store the lemongrass oil in a cold room with other essential oils. Like fine wine, it must be kept cool or it could spoil and ruin its bouquet. When it's time to formulate ingredients for a cream or lotion, a technician blends lemongrass oil with other essential oils. Just a few drops make a difference you can smell. They also use lemongrass oil to enhance the soothing qualities of bath crystals. The technician first sifts Epsom salts and baking soda into a bowl. He adds measured amounts of the blend to sea salt crystals. He stirs the ingredients by hand to evenly distribute them in the mix. The bath salts are now ready for an infusion of the double distilled lemongrass oil. He adds it to a submixture of other essential oils to create a blend with calming effect. He pours the essential oils onto the crystals, and they soak into the tiny spaces in the particles. They then add some more aromatic spice, a freshly ground blend of lemongrass, turmeric, and other ingredients. He sprinkles the herbs onto the crystals and folds them into the blend. The final effect will be skin tingling and rejuvenating. Incorporated into many products, lemongrass oil will awaken the senses. Fly fishing uses artificial lures called flies rather than natural bait like worms. A fly is a hook that has materials like feathers tied to it with thread to trick the fish into thinking there's an insect floating on the water. To make your own flies, you use a fly tying vise. This fly tying vise has pockets in its base to hold your materials and sturdy steel jaws to grip the fish hook while you tie those materials onto it. This machine makes the sand molds for casting the metal pocket bases. It deposits moist sand into a flask to form one half of a mold, then rolls over the flask to a pattern on the other side. After spraying the pattern with a non-stick coating, a worker sifts sand onto it. Then the machine deposits sand on top to form the other half of the mold. It compresses the sand with roughly 4.5 tons of hydraulic pressure. The pattern sandwiched at the center forms the mold cavity. A machine separates the halves to remove the pattern, then puts them back together. In the casting area, workers heat pieces of bronze to approximately 1,922 degrees Fahrenheit, melting them down. They remove the pot from the electric furnace and place it in a pouring shank. They pour the molten bronze down a channel leading to the mold cavity. After about a half hour, Once the bronze has cooled and solidified, they flip the mold onto a vibrating grate. First, the impact and then the shaking break the mold. The sand falls through the grate, while 4 connected bronze pocket bases remain on top. Once they're cool enough to be handled, a worker saws them apart. The bases go into a rotating drum filled with tiny steel beads. As the drum spins, the centrifugal force throws the beads against the bases. This removes all remnants of sand and polishes the surface smooth. The bases go onto a computer-guided milling machine. It drills a hole to affix the mounting piece for the stem that holds the head of the vise. The mill also cuts a circular hole at the center of the base for a decorative coin bearing the manufacturer's logo. They finish the bases with a clear protective coat, a proprietary formula that prevents the bronze from oxidizing. The vise's other parts are machined out of metal bars. Here, a computer-guided lathe transforms 2 square steel bars into the vise's jaws. First, it cuts a small half circle on one piece for the cam that opens and closes the jaws. Then it turns the ends to form a point. The entire transformation from bars to jaws takes about 90 seconds. They place the jaws, one at a time, into a press and make a slight bend to set the correct spring tension. They verify the depth of the bend with a specialized measuring tool, then send the jaws to an outside facility that applies a black protective finish. When the jaws come back, workers assemble them. First, they put the cam through the semicircular hole. Then they compress the jaws in a vise and slide an aluminum head onto the back. When the jaws come out of the vise, they expand to their original position, retaining the head. Workers apply the manufacturer's sticker, then thread a brass thumb screw that you turn to lock in the position of the head, which swivels left, right, or 360 degrees. They then bolt the handle into the cam. When you depress the handle, the cam opens, opening the jaws. On the reverse side of the jaws, they mount a clip for holding the feathers, yarn, or other materials you're using to tie your fly. Then they glue the logo coin into the pocket base. They install the mounting piece for the stem, then the stem itself. A thumb screw on the mount holds the stem in place. The head connects to a swivel at the top of the stem. The jaws securely hold the hook while you tie your fly, using anything from feathers and fur to tinsel and beads, creating your imitation of an appetizing insect or tiny fish.